if you think about your hand, your fingers are going to represent the common angles. So this is our 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay? For sine and cosine, we are going to follow this pattern. It's a square root over 2, okay, for both of these. Sine is going to be top and cosine is going to be bottom. So, at 0 degrees, if I fold down my 0 finger, if I want sine, that would be the number of fingers above the one I folded down, which is 0. So it would be the square root of 0 over 2, which is 0. So sine of 0 is 0. Cosine is the bottom. So if I ask for cosine of 0 degrees, how many fingers do I have below the one I folded? 4. So it would be the square root of 4 divided by 2, which is 1. So we get that sine of 0 is 0 and cosine of 0 is 1. Isn't that what we had before? We were doing it before from our picture. And sine was y over r, 0 over 1, and that gave us 0. Cosine was x over r, 1 over 1 gave us 1. So at 30, so you fold in your 30 degree finger. So the sine of 30 degrees, sine is the number of fingers above the one we folded in, so that would be 1. So it's the square root of 1 over 2, which is, square root of 1 is 1, so just a half. Isn't that what we wrote down yesterday for the sine of 30? If I want cosine of 30, cosine is the fingers below, so we have 3 fingers below, so cosine of 30 is radical 3 over 2. If I want 45, sine would be square root of 2 over 2. Cosine would be square root of 2 over 2. If I want 60, so sine would be square root of 3 over 2. Cosine would be square root of 1 over 2, which is a half. At 90, my pinky will not fold in on its own. I have to hold it. So 90, I have 4 fingers above, so sine would be radical 4 over 2, which is 1. Cosine is the fingers below, so 0 over 2 is 0. Do you guys understand that trick? So now if I said, tell me the sine of 60 degrees, you can fold in your 60 and say, oh, it's radical 3 over 2. Or if I said cosine of 45, so you fold in your 45, cosine's the bottom, so radical 2 over 2. Now, that's how to get sine and cosine, and if you know those, you can get secant and cosecant by doing the reciprocals, right? So let's talk about tangent. In the last chapter, I gave you a quotient identity, and I told you that tangent was sine over cosine. If sine were radical 3 over 2, and cosine were 1/2, when you divide those fractions, you flip and multiply, right? And those 2's end up canceling. So for our trick, for tangent, we can just do the square root of the top over the square root of the bottom. So I asked for the tangent of 0 degrees. You fold in your 0. So I have 0 fingers above and 4 below. So it's the square root of 0 divided by the square root of 4, which is 0. If I wanted, you need me here.
Yeah, I just have a question.
Okay.
What is that one? So I think I only missed 1.5 on that.
I could have mistyped it too.
Okay, thank you. This is really scary.
So if we did 30, fold in your 30. So tangent square root of the top over square root of the bottom, so it'd be radical 1 over radical 3. Square root of 1 is 1 over the square root of 3, which would turn into radical 3 over 3, like we had yesterday. Okay. 45. Radical 2 over radical 2 is 1. 60. Radical 3 over radical 1. Radical 3. 90. So radical 4 over radical 0. Undefined. Can't divide by 0. I don't know. Can you guys fold in your pinky? Like, mine will not. It just won't.
This finger will do it.
Yeah, I can't
I
do
can,
it.
but then this one moves.
I mean, I can't even, I can't. I physically cannot. I always feel kind of silly when I have to like, hold in my finger. Do you guys understand that trick? Okay. It's the same as sine, but you're looking at the fingers below. So it's the square root over 2. But whatever angle you hold in is sine. And the fingers on top is
I'm trying so hard. I'm trying to figure
Tangent would be radical 2. Sid, watch.
I can do like this.
Actually, the more I look at it, the better.
Mine looks like one of those flappy hands, like the ones. I just wrote like this. Oh, Hallie, I can't do this. I can't do this. I can't do this. Mine looks like those flappy hands. Oh, I can do it. Like that.
Look at the size of your hands.
Okay.
Check 2. The check 2.
I know, but scientifically.
You're paying for it all at once?
But they don't go all the way down.
Quarters.
Okay. What other questions do we have? Other than can you fold your fingers?
It makes you see which one the quarters here.
Okay. So, let's see. You have all of these pretty much written down in your notes, but I'm going to fill in this table. We are going to talk more about this. Eventually, I will add the other 3 trig functions to this table, and we'll have a complete table, and that will be pretty much everything. But for today, we're just going to focus on sine, cosine, and tangent. We can do our hand trick. If you don't get the hand trick after today, we're going to keep using it today. If that doesn't make sense to you, see me. I can give you other ways. The hand trick just seems to be the fastest for most people because you can get that immediately if I ask you for one of those functions. Okay. So, I just want to fill in these values. And we already just ran through all of them, but I want you to use your hand trick as we go through here to help us. Sine of 0. So if you fold in your 0. Sine is the square root of the number of fingers above over 2. So in other words, it's the square root of 0 over 2, which is 0. You don't necessarily have to write the square root of 0 over 2 unless you want. Cosine would be what? So fingers below, so that's radical 4 over 2, which gives you 1. Tangent is top over bottom, so radical 0 over radical 4, which is 0. Or if you know sine and cosine, what's 0 divided by 1? 0. Okay, 30. Fold in your 30. So sine will be the square root of 1 over 2, which is 1/2. Cosine would be the square root of 3 over 2, which does not reduce. Tangent would be radical 1 over radical 3, which gives us radical 3 over 3. (45) Sine would be radical 2 over 2. What's cosine? Radical 2 over 2. Tangent, radical 2 over radical 2. That's 1. 60. So sine is the top. So that would be radical 3 over 2. Cosine is the bottom, so that's radical 1 over 2, which is 1/2. Tangent, radical 3 over radical 1 is radical 3. Okay. 90. So if you fold in your pinky, so sine would be square root of 4 over 2 so 2 over 2 is 1. Cosine, we have no fingers below, so square root of 0 over 2, which is 0. Tangent would be radical 4 over radical 0, which is undefined. As far as patterns, if you're looking at this table, you can kind of see if your pattern for sine is square root over 2, square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. And cosine is just that in reverse, because we know they're cofunctions. So sine of 0 has to equal the cosine of 90. Sine of 30 is equal to cosine of 60. Sine and cosine of 45 are equal. Tangent is just sine over cosine. 0 over 1 is 0. 1/2 divided by radical 3 over 2. It's radical 3 over 3. So there are lots of patterns going on here. Do you have questions? So all I want to do for the rest of class is just use these values. Okay, I want to try, when I ask you a question about a value, I want to try to figure it out versus just looking at the table that we copied down, because we want to learn these moving forward. The first two are going to kind of compare our values in this table. I want to know if this would be true or false. Tangent of 25 degrees is less than the tangent of 23 degrees. Let's just look at our table for a minute. What's happening as our angle goes up? Are these numbers getting bigger or smaller? Do 0. Radical 3 over 3 is like 0.7, 0.8, 1. What's happening to these? They're getting bigger. So the bigger the angle, the bigger the value. So which of these things should be bigger? Tangent of 25 or tangent of 23? 25 should be bigger, so this one is false. Okay. We didn't do secant and cosecant, but we could figure them out, couldn't we? So cosecant is the reciprocal of what? Sine. Okay. So if sine is 0, then we know cosecant would be undefined. If sine is 1/2, cosecant would be 2. This would be 2 over radical 2. 2 over radical 3. 1. Are these values getting bigger or smaller? Smaller. So this time the bigger angle is a smaller answer. So is this true or false? True. Okay, so I just wanted you to compare those numbers in the table to answer those. Any questions there? I want to simplify each of these things. Two cosine of 33. So this means 2 times the cosine of 30. So if I want cosine of 30, if I fold in my 30, what's the value of cosine? Radical 3 over 2. Okay. 2's cancel, and you get radical 2. Want to caution you, if you type cosine of 30 in your calculator, it will give you a decimal, not radical 3 over 2. And I want exact answers, so I expect the radical form. Okay, this one, it's really hard to see. This is a sine squared 45 and a cosine squared 45. So sine squared 45, that means you're going to take the value of the sine of 45 and then square that answer. So 45, fold that in. Sine is the top, so that's 2 fingers. So sine of 45 is radical 2 over 2. Minus 2 times sine of 45, we just said was radical 2 over 2. Times, what's the cosine of 45? Plus the cosine of 45 squared, so radical 2 over 2 squared. Okay, if I want to simplify that, radical 2 over 2 squared. So radical 2 times radical 2 would be 2. 2 times 2 is 4. And this would be 2 times radical 2 times radical 2 is 2. 2 times 2 is 4. I get 0 for my answer on this one. 7 alright? One more. This is tangent of 45 degrees plus tangent of 60 degrees squared. Tangent of 45. So fold in your 45. Tangent is the top over the bottom. Radical 2 over radical 2 is 1. Plus tangent of 60. So fold in your 60. Radical 3 over radical 1 is radical 3. And I'm going to square that. How do you square something like this? Oil. So we get 1 plus radical 3 plus radical 3 plus radical 9, which is just 3. Adding like terms, it's 4 plus 2 radical 3. Any questions on that? Take a second and draw this picture for me. You're trying to find the values of each of our variables here. To do this, we are going to have to set up some equations and solve. Keep in mind, your trig functions only work in right triangles. Do I have, how many right triangles are in my picture? 2, because each side of it. Okay. If I look at this triangle on the left, I don't really have much information. I know I have a 45-degree angle, but I don't know any of the side lengths. So I'm probably not going to start with that one. If I look at the one on the right, I at least know that the hypotenuse is 12. So I'm going to start there. We either have to solve for B or D first. If I wanted to solve for B, okay, I know this angle is 30 degrees. These are the sides that I'm going to have to use. So tell me, in terms of opposite adjacent hypotenuse, from this 30 degrees, B would be the opposite side. 12 is the hypotenuse. Which trig function involves opposite and hypotenuse? Sine. So what we can do is say the sine of 30 degrees equals our opposite side, which is B, over the hypotenuse, which is 12. But sine of 30. What's the sine of 30? 1/2. So I can replace that with 1/2. Multiply over my 12. And B is 6. Alright. So I have one of my values. 3 to go. If I want D, at this point you now have options. If you have 2 sides in a right triangle, how could you get your third? Pythagorean theorem. And that's certainly an option, probably one of the fastest ones. I'm trying to practice my trig function, so I'm going to make you set up another trig function to solve this one. But on your homework, you could do Pythagorean theorem, I don't care. From this 30, D would be what side? Adjacent. I try to use a number given in the problem if at all possible, just in case I messed up on B, then I don't mess up on all of them. So let's use the 12. So I have adjacent and hypotenuse. What trig function is that? Cosine. So I could say the cosine of 30 degrees equals my adjacent side D over my hypotenuse 12. Cosine of 30 is radical 3 over 2. Just like before, I don't want decimals. So if I multiply my 12 divided by 2 is 6, so I just get 6 radical 3 for that side. And you would have gotten to the same point if you did your Pythagorean theorem. You just have to break down your radical. Okay. Now we have to find A and C. The good news is I know my D now. So this side is 6 radical 3. Does anybody know a short way of finding what side A would be? People are mouthing things at me, but nobody's You're probably right. My picture is not drawn to scale. If this is 90 and this is 45, what's that angle? 45. If two angles are the same, so are your sides. So if this is 6 radical 3, A would have to be 6 radical 3. Now you could certainly get it by setting up a trig function, but that does save us some trouble. Okay. I need C. So we can either set up a trig function or do Pythagorean theorem. What do you want to do? Trig function. Okay. So, from here, this is 45. We have options. If I use this side over here, that's opposite. C is my hypotenuse. So what trig function would that be? So I could say the sine of 45 degrees equals my opposite side, which is 6 radical 3, over my hypotenuse, which is C. Sine of 45, fold in your 45. Sine is the square root of the top over 2, so square root of 2 over 2. Since C is on the bottom, let's cross multiply here. I get C radical 2 equals 12 radical 3. Divide by radical 2. Can you leave the square root on the bottom? No. So if you multiply by radical 2 on top and bottom, you get 12 radical 6 over 2, or 6 radical 6. So on these types of problems, if you have to first of all make sure you're looking at a right triangle. Then, if you know two sides, you could do Pythagorean theorem. Otherwise, you need to set up trig functions from your acute angles, not the right angle. Set up trig functions from the acute angles to solve for the others. Let's try maybe one more, and then I'm done.
How did you get A?
I knew that my triangle was isosceles because these two angles were both 45. So if those angles are equal, then the sides touching them have to be equal. Are there any values that we automatically know looking at this one? P. Since these two angles are 45, they're the same, that means these sides have to be the same. So P would have to equal 15. Let's just do Pythagorean theorem to get R. So 15 squared plus 15 squared equals R squared. What's 15 squared? 225. Square root, we're talking about a length, so it would be positive. How would you break down 450? $225 and 2. Square root of 225 is 15, so R is 15 radical 2. Okay. Now I know that. Let's get T. I failed to draw this. This has to be a right angle, otherwise we can't solve this. So I am focusing on this triangle. The side I know is the hypotenuse. If I'm looking from my 30-degree angle, T would be my adjacent. What involves adjacent and hypotenuse? Cosine. So I could say the cosine of 30 degrees equals T over 15 radical 2. Cosine of 30 would be radical 3 over 2. So you multiply by your denominator. You get 15, 2 times 3 would be radical 6 over 2. Q, you could do Pythagorean theorem with all these radicals. It might be a bit ugly, so let's just go ahead and do a trig function. If I'm viewing from my 30-degree angle, Q is the opposite, and 15 radical 2 is my hypotenuse, so that would be sine. So sine of 30 equals my opposite side, Q, over my hypotenuse, 15 radical 2. Sine of 30? 1/2. So multiply 15 radical 2. And you get 15 radical 2 over 2 equals Q. Again, I'm saying exact values on these, so I need radicals, not the decimal your calculator would tell you. Questions on that? We have 20 minutes. That's my stopping point. Yesterday we ended at 37. So this is the last piece to add on, and we'll turn it all in tomorrow.